Okay, so welcome to this presentation titled Reclaiming Discipline in Client-Side Web Development. So my name's James Roper. I work for a company called TypeSafe. TypeSafe has an office here in Stockholm. We do Play, Akka and Scala. And my role at TypeSafe is tech lead on Play Framework, which is a reactive Play framework for Java and Scala. So you may have noticed from my accent that I'm not from around here. So I've got this map. So I was up really late preparing these slides last night, and this is a bit embarrassing. I actually got the map upside down. So a bit of magic with HTML5. Hang on, let me check the button. There we go. Okay, so I'm from this country up here. It's called Australia. We're way up south. And I really want to thank you for having me here down under in Sweden. Now, it was a bit warmer when I left Australia. It was actually 36 degrees, and I hope my voice is okay because I've caught a bit of a cold here. This is actually a couple of days before I left Australia. Me and my colleague in the TypeSafe Australia office. Yeah, that's actually his office where he works from. We work remotely. I don't work there every day, but he does. Probably a bit more serious stuff now, my outline of the talk. So I'm going to be talking today about client-side development. So how many people here are Java developers? Good, you're at the right conference. How many people here write client-side JavaScript? Good, you're at the right talk. So what I'm going to be showing today is a series of things that you would never do in Java. And I'm going to show you some equivalent things that you probably have, and definitely I have done in JavaScript. And then I'm going to show you ways to not do those things in JavaScript so we can reclaim engineering and discipline in client-side development. So to start off with, I'm going to show you a pull request. Now you probably can't see it that clearly, but you can see here that I'm adding Guava joiner, who here has used the Guava joiner for joining strings. I've added it to my project, so I've got the source code and I've copied it in there. Who here would merge this pull request? Anyone? Who here would have a problem with it and probably... So you just sit on it and do nothing? Like, you got to merge a pull request eventually or reject it. The problem with this pull request, of course, is that I've copied source code from an open source library into my project. Now, quite some time ago, tools like Maven and new evolutions like Gradle and SBT kind of walked into the scene. And you no longer have to do this. You don't have to copy code into your project. You can add a dependency on it. But then when we get to this pull request here, you can see I've added a jQuery to my project. Who here has ever done this in a project, copied the jQuery source code? Pretty much everyone. I mean, it's what you do, right? But why would you not accept that for Java, but accept it for JavaScript? I mean, what's so special about JavaScript that you can drop all these practices? So, I mean, one problem is, I guess, tooling has not been there for JavaScript, but things are changing these days. So particularly, people here, who's using Maven or Ivy or anything that goes to Maven Central? Right, looks like pretty much everyone. So you may or may not have heard of this, but there's a project called WebJars. And WebJars is actually it's not a TypeSafe thing, but it was made by one of my colleagues before he joined TypeSafe. His name's James Ward. And the idea is basically take the releases of JavaScript projects, package them as jars, deploy them to Maven Central, where any Maven SBT, Ivy, Gradle, Ant project can go and download it and access it without having to embed things directly into your code, into your project. So having a look at WebJars, I actually meant to do a count of the number of projects. I think it's over 250 different WebJars projects that are available. This is the page that shows them. You can see this is just up to AN on this page, and it shows you all the versions that are available, and this, you can choose which build tool you're using. This is the syntax for Play2 or SBT to add a dependency. So pretty much every single major project out there, JavaScript project out there, is available as a WebJar. They tend to lag maybe by a few days. So I know Bootstrap 3.1 was released a week ago or so, and it was about 2 days later that the WebJar came out. So that's, you may be a couple of days behind, and that may be a lot in the JavaScript world, but hopefully it shouldn't be too much in the enterprise world. So how do I use WebJars? So today I'm going to be showing, I'm a Play developer, so I'm going to be showing you examples from Play Framework, but WebJars and nothing that I'm showing to you here is actually necessarily specific to Play Framework. It's just that Play Framework makes it very easy to do this stuff. But you can do it in any Java framework. So here I have an extract of my play build.sbt file. And you can see I've added some dependencies, Bootstrap, Knockout, Leaflet, and that's all I need to do. And then those dependencies are downloaded just like normal jar artifacts. But then when I want to include them, so let's say I want to include the Bootstrap file, then I can add this dependency here, this into my HTML. And you can see here I've got two calls. So this is Play Scala template syntax. This is the reverse router that looks up the route, so the path for the WebJar asset, and this one actually locates the specific asset that we want. So that's saying I want the Bootstrap, minified Bootstrap JavaScript, and that will end up being substituted with the path of the WebJar. Now, actually, what ends up in that URL that comes back is the version number. So it's nicely versioned. So you can use caching, and it does use caching, and this can actually work with CDNs as well. You can put it in a mode where it switches to a CDN. Of course, you can also use it with CSS, exactly the same thing. You can use it with images. Anything that you want to serve up with a web server, you can use WebJars with. So, we've got our dependencies. Let's look at a new pull request. So I've got some service here, probably a bit blurry to read, but we've got some service, public static list foo, get all foos. I then instantiate a new foo, DAO, and I call .findAll on it to get my, my list of foos. Who would merge this pull request? What's the problem with it? It's instantiating the foo DAO. I mean, it's static for a start, and instantiating the foo DAO at the point that it uses it, which means you can't sub in a different implementation. It's very difficult to test. The problem is it's not using dependency injection. And so here's a similar JavaScript thing. I'm using WebJars this time. I've got my Leaflet WebJar, and then I've got my main.js file. And then in here, probably a bit hard to read, but I just call map equals l.map. Okay? This code, how can I test it? And this is done all the time. Who writes code that kind of looks like this? No one. Okay, you're all better than me. So for dependency injection, I've chosen to use require.js and show require.js. Require.js is designed to make JavaScript modular and handle load-in of modules. But of course, because it separates where you get the module from with where you use it, you can inject other modules in place of where you're going to want to use it. And so it can be very effectively used to do dependency injection. By the way, who here does use require.js? And who doesn't? Okay, so a few people. So for those that aren't aware of what require.js is, require.js is an implementation of a specification called AMD, which basically specifies modules and how they can be loaded and asynchronously loaded. So a very brief introduction to Require.js. You can see here I'm defining a module. So I pass in a function that does that definition. So here it's asynchronous. So this function won't actually be called until the module gets used. I'm then returning an object that's got a few properties. So the name of this object is duck, and it's got a speak function which will quack on the console. So this module is my duck module. And then I can use it by saying require, and I specify I want a duck. And then I have a function, and this takes that duck dependency, and then I'm logging what does a duck do, calling the duck.name, and then calling duck.speak. Now, of course, just requiring something else from somewhere else directly like that doesn't really achieve anything. What's more interesting is when you define a module that depends on other modules. So here I'm defining a farm. I can, in my define statement, declare two dependencies. I depend on a duck and a pig. It's a duck and pig farm. And then I can have my names, duck.name and pig.name. And I have a commotion function. And so when I call commotion, it calls duck.speak and pig.speak. So the implementations of duck and pig are separate here. And which one I'm using is not can be dynamically chosen at runtime, which we'll see comes very helpful in testing later on. Okay, and then finally here I've got putting it all together. So one practice in Require.js, you can actually put URLs directly into your dependencies, but they recommend against doing that. The best way to do it is to alias everything. So I have an alias. I'm saying farm should go to the farm file in the current directory. Duck should go to the duck in the animals directory. Pig should go to pig in animals directory. And then this is how I start up my whole application. I use a require statement there and to get the farm, and that's going to cause a big commotion. Okay, so this is with all local files, but before I talked about WebJars and using WebJars. What does it look like when we want to use WebJars? So in Play Framework, and WebJars has this support, does provide some kind of generic support for all frameworks, but in Play Framework we kind of have it built in. So you can specify, here I'm looking up the Require.js, this is how to then use Require.js from the markup. So I'm using Require.js WebJar, and then you pass in this data main attribute, and that tells Require.js this is the what I should use to actually start up my app. So now this is what it might look like with WebJars. So in WebJars we have this kind of plugin format for paths in Require.js. So you can say WebJars, bang, and then the file name, and that can be prefixed if you've got multiple files on the path. It will find a file with that name. So now this is a little bit hacky here because you can't simply use a path mapping. You have to use this map for everything. That's because this is already configured to be a path mapping, and Require.js doesn't support recursive path mapping. So instead you kind of use this map thing here to map to a path, which WebJars will then map to the actual file name. And so you can see here I've got an application where I've got a map JavaScript file and it depends on leaflet, and then I can get that map and initialize it. And then using WebJars Require.js, this is the WebJars Requires plugin. This will return a special route that comes with all that Require.js configuration, doing that mapping with that WebJars exclamation mark plugin. So that's Require.js. What's the next thing? So now I've got a bit of play code here. So in play we have actions that handle, which live in controllers. Actions handle an HTTP request. So here's my getFoo action. It returns a result, takes in an ID, opens a database connection. We can see we're building up some SQL here. Should be fine because that's a long, so we probably don't have to worry about SQL injection there. And then we get that result, and then we build up some HTML here and return that, and then finally close the connection. So would anybody merge this pull request? Would anybody reject it? Okay, I've seen a few hands saying they would reject it. Why would you reject it? Well, it's obvious, right? We've got SQL here, we've got HTML here, we've got looking up a connection and closing it. We're mixing all these concerns together. Okay, and rule number one of writing maintainable web applications is to separate concerns. Your database access should be with other database access. Your HTML generation should be probably in a template somewhere doing HTML, and everything that puts it together, well, that goes in your controllers. Anybody written JavaScript that looks like this before? So we've got a load foo function, we do an AJAX call. On success, we look up the foo element and we append a div and put some style in there and put the text in there. Has anybody done that before? I mean, this is how I wrote JavaScript for many years. This should be, anybody who's been doing JavaScript development with jQuery, this should be very familiar with, and it's very common. But it's exactly the same problem as with the Java pull request. Okay, we're doing AJAX, we've got HTML in there, looking up stuff out of the DOM, style sheet stuff, it's all mixed. You can't test it, or you can test it, but you've got to test everything working together. You can't say, well, I know that the AJAX call is doing right because, and then if you change the markup, you've got to change all your tests everywhere. There's no separation of concerns here. So I don't actually have any code samples to show right now to show separation of concerns, but what I will be doing later is some live coding, and you can see a real web app that I've written that has some quite non-trivial JavaScript in it, and we'll see how we separate concerns in there. But the sort of things that you want to separate out in your app, you want to, I mean, the purpose of separating stuff out is to make things easier to comprehend and easier to test. Okay? If your HTML generation is all in one place, then you can not worry about that when you're looking at your business logic. Business logic is all in one place and no HTML generation. It's easier to read, easier to comprehend, and separating out making AJAX calls, again, it makes everything a lot easier to understand, and you can sub in and sub out different changes very easily. And of course, testing is very important, and we'll see that quite soon. So, as I said before, things that we want to split out, we want to split out AJAX. And an important point to make here is you want to use AJAX with promises. So who here knows what a promise is? A few people. Okay, who doesn't know what a promise is? Probably about 60% doesn't know what a promise is, and about 40% knows what a promise is. So a promise, who knows what Java util concurrent future is? Right, a lot of people have come across that, and often it's kind of a similar sort of thing, but completely different. With Java futures, it's a value that will be available in the future, but the only thing you can do is call get on it. And that means the only way to ever access it is to sit there waiting. So with Java futures, here's a future, but you've got to wait there, you've got to sit there waiting for me to do it if you ever want it. Okay, with JavaScript promises and with promises and futures in other frameworks, so in Scala and Play, it's it's something that is a value that will be available at some time in the future. So it's a promise to give a value at some point. And then you can attach a callback to say, when it's available, then do this. And the sort of things that you might do with those callbacks is you might transform it to another type of feature. So you might have a promise for, in the case of Ajax, you'll have a promise for a response from the web. And you say, okay, when I get this, then I want to transform that response into a certain data object that this other API can use. And so that's called, in the JavaScript promises, particularly with jQuery, you do that using the .then method. So you pass in a callback, it takes the triplet of things, the data, the status text, and the XHTML HTTP request object, and then you can convert that to some sort of object that your application, the rest of your application, can understand. And the nice thing about these promises is that they're nice and composable and they're easy to test. So with a callback, or you can, if you're trying to test it, then somehow, if you're going to mock a class, you've got to somehow capture that callback. Whereas using promises, if you mock a class, you just return the promise, and then that promise can do things. For example, that promise could already be redeemed and could execute calls immediately on it. So you don't have to worry so much about trying to capture all these callbacks and all these callback hell. You also want to separate DOM manipulation, and there are three main ways to do this. One is using templates, so there's a number of client-side templating engines. You can use a framework, so I like Knockout.js, Backbone, and you can also use manual encapsulation, of course. You can write your own kind of JavaScript class that goes and generates some JavaScript, some HTML using jQuery, or even just using string concatenation. The point is to somehow get it out of your code, all this HTML, so that you're not worrying when you're reading kind of the important parts of your JavaScript, what the actual markup is going to look like. And other things to mock out are browser APIs. So things like history, storage, WebSockets, event source. You want these to be separated. You don't want to have to, when you're testing or when you're looking at your code, worry about how these actually work. You want to be able to sub in different implementations of these so that you can easily mock them and when you're testing. And we'll see that a bit later as well. And of course, anything else that would be mixing concerns. I mean, there's 100,000 things that your application could do that there might be something of this type and something of that type, and they shouldn't be mixed. So, another pull request. I've got an adder, and I've got a method called add4. It takes an integer parameter called 2, and before it was adding 3, which was a bug, but I fixed the bug to make it add 4. So actually, I didn't actually test this. This should have an int parameter there, but let's forget that. Would you accept this pull request? I mean, let me ask you, how did this bug get in there in the first place? It's a pretty easy method to test, right? Just pass in an argument, see if it adds 4. If you did that, you would know that it works. This bug never would have happened. The problem with this pull request is that there's no tests. I certainly wouldn't merge it. Here's JavaScript equivalent. We're using require.js this time. We've got our add4 function, and again, there's no tests. But we merge this all the time. I mean, who here has merged a JavaScript pull request when there was no tests? I think we all have, because I think most of us have probably not written any tests for JavaScript. So, let me just show you that again. I spent about 10 minutes working on this animation. It's the same as on the Mocha website, and I thought I was going to like download the logo, and then I saw, oh no, their logo moves, but then, yeah, I got it looking nice, so just a couple more times. I really like it. Okay, so there are a lot of JavaScript testing frameworks out there. I'm not particularly married to one. I chose Mocha because I could. One reason why I chose Mocha is that it doesn't require a DOM. Okay, so I mean, I'm talking about separation of concerns. If I'm using a test framework that requires there to be a DOM, then that's a bit of a problem. And it's a recent JavaScript survey. I forget which organisation does it, but Mocha is actually catching up to Jasmine as the #1 test framework. So I'm going to be showing Mocha today, but really there are a lot of test frameworks out there that you could use. My point is that we should be doing JavaScript testing. Don't use this as an endorsement that Mocha is the framework that everybody should use. So Mocha is a JavaScript test framework. Let's have a look at what a test looks like. So this is running on Node.js. We've got a require statement here, getting in the assert module. So with Mocha, it will go and look at your JavaScript files, and it will ensure that it's already available in scope, so you don't actually need to require Mocha. And then you have, it's kind of a BDD sort of style. I'm describing that adder JavaScript that I wrote before, and then here I'm describing the add for. I don't need this nested describe, but you can do it as it's been done here. And I'm saying it should add 4, and then assert equal 5 is equal to add 4 to 1. And that's a simple test in a nutshell. Okay, so what about if you wanted to do use require.js? So as I said, I'm running Mocha on Node.js, and one of the difficulties with using require.js and Node.js is that Node.js has its own module loading system, which is kind of like which is similar to the CommonJS spec, but not quite. And require.js obviously provides require, and they both use the same keyword called require. So that causes a bit of a problem because they both behave differently. Node.js's require is actually blocking. Node.js is supposed to not be a blocking framework, but when it loads JavaScript, it blocks. And it will go and look up that file and load it, while require.js is non-blocking, and so its require call will takes a callback to invoke once all the dependencies are loaded. So what require.js does to work around this is they have their own framework. They have their own version of require.js that is kind of designed to work in a Node.js environment. And so you can require that. So the name of the script in the require.js distribution is actually called r.js. I probably wouldn't call it that if I was putting it in my code, because what does r.js mean? I think require.js makes a lot more sense. But of course it's all aliased, so I'm just calling it require.js here. And you can see here I'm this time loading my adder dynamically, and I'm got exactly the same test. Now, require.js does allow this synchronous loading, but of course it prefers doing asynchronous loading, and so we can also actually, now what I was going to talk about next is mocking. So, okay, that's fine for just loading a single thing, but our adder function is crazy trivial. It doesn't have any dependencies. So what about mocking? Now for mocking, there's a framework which not many people have heard of. Who has heard of Squire.js? Good. I'm going to teach you something today. So Squire.js is a mocking framework from Require.js. They've got this incredibly nice-looking logo here. I don't know what's with that, because JavaScript libraries usually have the sexiest logos, and that's not really. But anyway, I get my Require.js loading from Require, and then I use that to load Squire. Now, I can't actually use the Node.js Require to load Squire, because Squire expects Require.js to be there, and Require.js, when it loads, it will set itself up there so it overrides Common.js for the module that it's loading. So I've got to use Require.js to load Squire. And then, like you can see here, I can create a new injector, which is by calling the Squire constructor. And then I can say injector.require and pass my adder, and then have my asynchronous thing happening here where I pass in the function and do my assertion. Now, there is one problem with that, and that is that because this runs asynchronously, that means the test finishes before the assertion runs. Mocha actually supports asynchronous tests, and it does this by adding this done function. So I've removed a bit of boilerplate here. It adds this done parameter to the function. So if that function has a done parameter, then Mocha knows this is an asynchronous test. And so it waits for you to call done. So then I can call assert and so on, and I've got my done function there to say it's done. And so using all this, I can know I can do my tests asynchronously. Okay, but what about actual mocking? So we haven't shown mocking yet. We've shown how we can use our Squire.js framework to load a dependency with Require.js asynchronously. But here I've got a mock animal. So you remember before I kind of had an example of a farmyard of animals. We had a duck and a pig. And I actually want to test my farm. So I've created a mock animal, and it's a class. It's got a name then, so here's the name. And I've got the speak function here, which increments spoken. And so I can then run assertions on spoken to make sure that speak was called and things like that. So I can do this by creating my injector, and then I can mock a duck with a mock animal, which is a mock duck. I can mock a pig with a mock animal, which is a mock pig. And then I can do injector.require, require the farm, and then I'm doing a deep equals on the farm.names. So here you can see that I'm doing mocking my dependencies, and we've got another test here. So this time, rather than putting mock animal directly into the injector, I'm capturing these references to duck and pig, and so then I can call my farm.commotion and assert that each one was called once. Now, I know something that you may have noticed here is we're starting to get a lot of boilerplate for tests, and this is one of my #1 pet hate anti-patterns. I could give a whole talk on this by itself, and it's not specific to client-side development. It's specific to anyone that writes tests in any framework, except possibly Haskell developers, because they're off in some crazy land where everything's awesome. But the danger here is but these are only tests anti-pattern. So who's ever said, well, you know, these are only tests, so we don't really need to worry about reviewing them, or these are only tests, so it doesn't matter if we change them just before doing a release, or these are only tests, so we don't really need to worry about applying best practice engineering principles. Lots of people have said that, or come across people that have said that. You wouldn't have said that yourselves, right? So I hate this personally. Anybody ever seen a test file where you've got 20 tests, and each test has about 20 lines of code, and each line of code is almost identical apart from like one line of code in each test is slightly different? Anybody seen that before? Okay, and anyone gone to like go and update something. For example, adding a new parameter to a constructor. And you go and your production code is all really well engineered. So you go and you put in your bit of, you update your bit of code, and then you only have to change the production code in 2 places for this interface change that you made, and it only takes 5 minutes to get this working. Then you run the tests, and you've broken 100 tests, and you've got to go and manually copy paste, copy paste, copy paste, because there's things using this constructor that you added a parameter to 100 times over in 100 different tests. Tests are just as much an important part of your code as the production code, okay? They say whether your code is working or not, and working code is pretty important. So you should not throw out your engineering practices when you get to tests. And so the big thing is don't repeat yourself, okay? Make your tests dry. So for these 2 tests, I've pulled out all the common code, okay? In both tests, I'm instantiating an injector. So what I've written is I've written a function with farm. It returns a function itself. Now, Mocha, you saw before, when you call the it call, takes a function that accepts an argument called done. So I'm returning a function that sets an argument called done. And the injector is common, creating the duck is common, creating the pig is common, injecting the duck into Squire and mocking the pig is common, and then doing the actual require call is common. And then the only thing, I put all the logic in this test callback, and I call it with my farm, my duck, and pig. And of course, in my case, done was also common between them, so I can call done. So those 2 tests that I had before, which were a screen full of code, here's the first one. We've got the name of it, we call with farm, and we don't care about the nice thing about JavaScript. If you don't care about arguments in a callback, you can just ignore them. So all I've got here is 1 line of code for my assertion, and then here you can see these tests, all they're doing is doing the actual call and then the assertions, or the call and the assertion in 1 line. So you saw that there was a lot of extra code in doing this mocking, but if you factor it out, you can end up with really nice looking tests like this. So that brings us to the end of my slides. But now I thought, okay, you've seen me doing all this. This is probably very applicable for Old MacDonald with all his farm animals, but how does it actually work in the real world? So I've got this application. It's called Reactive Maps. We're actually running it in the exhibition hall. You can see it running on the TypeSafe screen there. And basically what it is, so I'll start it up, I'll connect to it, and hopefully my internet connection will let me download those map tiles, but if not, it doesn't really matter. So what it is you've got a web server, and you can connect, and it'll just send your location to the web server, and you can see the location of everyone else that's connected. Of course, very boring if you're just looking at yourself there. So we've got set up some bots, which are kind of, you can see them walking around. This is ripped from North Carolina GeoJSON data, and you can kind of see them walking along these hiking trails. And I'm going to add a new feature that's going to do all the that's going to, when you click on a particular marker, will show how far this particular bot or person has gone. Now, I've actually already implemented the backend for this because this is a client-side talk. I don't need to bore you with the backend. So we're going to see, applying these principles, how we're going to do it. So to start off with, I'm going to create a new class called UserInfo. Now I'm using CoffeeScript here. Don't worry about that. CoffeeScript is just a different syntax for JavaScript. It just happens to be what we're using. So you can see here I use Squire.js to depend on jQuery. I'm going to return an object, and I'm defining a method that's going to have the user get the user distance for a particular user, but we identify markers in this application by email. Another thing that I've got is a marker renderer. This is where the pop-up gets rendered, and I'm going to add a new distance parameter in here. And what I want to test is my marker code, which is going to have to do the call on user info and then call the marker render to render it. So we've got some tests here, and I'm just going to shut down my application and run the tests. They should be passing. So they're passing at the moment, and I'm going to write a new test. So we want to, whenever the pop-up is clicked, we want to update the pop-up with the current distance that marker has travelled. So I've created a test here, and you can see I've extracted all the boilerplate into this test marker function, and with an interesting thing here is that I've put my dependencies that I'm mocking into an object so that when I add a new dependency, I don't need to worry about going and updating on my tests. I can just call that, I can just extract that out of the object. So I'm going to create a new marker. And then I'm going to, actually, one thing I should have done is start setting up my mocks. So first thing that I'm in here, I want to mock that user info. So you can see here I've got a user distance function. It goes and gets the users out of a map and returns it in a mock promise. So remember how I talked about returning promises? Really easy, because I can just return a mock promise. I don't need to worry about capturing callbacks. Now, the onClick function, unfortunately, on the marker does require a promise. So in this case, I'm simply going to capture that callback. So when it calls onClick, I'm going to capture that callback so that I can invoke it later. And the other thing that I will do is, in my pop-up, I want to mock, I haven't yet mocked the setContent method and the update method, which I'm going to call. So this will let me test that when I call setContent, that content was updated. So back to my test. So after instantiating my marker, I can call onClick, because that callback should have been added. And then I can verify that after clicking that, the marker, the pop-up, has the content. And you can see here, actually that's something else that I didn't do, is say how the marker renderer is going to render the distance. So here's the marker renderer. I add the distance parameter, and I'm going to replace that so the old behavior still happens, but the new behavior will simply put the user ID :distance, so I can run an assertion on that. So now I've written my test. I should run it, and it should fail because I haven't implemented this in marker yet. You can see that one test fails. So let's go into my marker, and where we bind the pop-up, we also want to bind an onClick. So when we click it, we want to get that user distance, which returns the promise. When that promise is done, we add a callback saying that takes the distance, and then we get the pop-up. We set the content on that pop-up to be the rendered pop-up content from the renderer. So you can see here I've separated out that rendering logic. And then finally I need to call update to ensure that the rendering updates. Okay, and now I should be able to test that. And I forget this every single time. I need to add my dependency onto the new user info. And it's still failing. So now we have a game called Tell Me Where I'm Going Wrong. Right, it can't find user info. That's right, because I need to go into my test marker thing here and create the mocked user info. So I'm creating the mocked user info. I'm then going to actually mock it, and finally pass it in as a dependency there so that my test can access it. And now we have a passing test. And let's just fill out the implementation of user info. So you can see here that I'm using that .then call on the returned promise to map it from the response data to the distance value. One more thing, or two more things, marker renderer. I'm just going to replace that. No, I didn't want that one. With something, it's simply going to, if the distance is defined, it'll just add the distance underneath it. And finally, in putting it all together, I need to put the mapping for the user info to the user info path there. And now I should be able to run my app again. And after connecting, and this is an eventually consistent system, so it might take a little while for things to look right. So you can see here, it's traveled 162 meters. We can click on another one and then click back here, 247 meters. So these guys are actually hiking very, very fast. So you can see there how I can apply these simple unit testing and mocking and separation of concerns and dependency injection into a real application. This, I do have to confess, so this is a Play application, and this stuff won't be available in Play till Play 2.3. You can, however, see my branch, which still has some hacks because Play 2.3 isn't out yet. But that can be loaded from there. But you can also download the Reactive Maps application by using TypeSafe Activator, which is a product that we have, to create a template, and it explains how it all works to you. So today we've seen a few things. We've seen how to use WebJars to get dependency management in JavaScript. We've seen how to do dependency injection with Squire.js. We've seen how to do separation of concerns in client-side JavaScript. We've seen how to test, how to mock, and best practices for structuring your tests. I hope that this will help you to add more discipline into your client-side development so that it comes on par with your Java development. So thank you for hearing me. I think we might have time for just one or two questions. Yeah, there's one at the back.
Thank you. I would like to understand what is the difference, sorry for generic question, but what is the general difference between separation of concern and single responsibility principle?
I guess single responsibility is a subset of separation of concerns. So if you've got a single responsibility, then obviously other concerns have been separated out from you, but you could have something that has separated concerns but has multiple responsibilities. So I guess single responsibility is a bit more strict than separation of concerns. I guess it depends on the size of the application as to what you should use. You can tend to over-engineer things where you end up with 100,000 files and it's hard to follow the flow because you're having to jump from file to file to file, and that's a bit of the danger with single responsibility. But yeah, it all depends. yeah, I guess you've got to make a judgment call. And I think a really good test of the judgment call is how easy is this stuff to test? How confident can I be? Can I write tests to make myself confident that when I deploy this, it'll work? And yeah, if the answer to that is I'm confident, then you've probably done the right level of abstraction. Okay, well, thank you.